Good morning, everybody. So many fresh faces here. What you did last evening? I have heard amazing stories about evenings at Amsterdam. So, well, okay, but those of you who are still alive and here, let's talk about Azure Search a little bit. How many of you have already worked with at least some search solution? Raise your hands. Okay, that's great. And do we have here some guys who have not experiences yet, but planning to build a search to some solution? Okay, so great. Now I speak a few words about search technologies that Microsoft has had over years. First, perhaps the most popular one we all know is a desktop or a Windows search that is running in our laptops and desktops. Later came a web search called Bing, and with a SharePoint we suddenly got the enterprise level search. Actually, SharePoint search, I have worked with it. I'm considering this beast practically as a Rolls-Royce of search world, but like a real Rolls-Royce, it comes with a price. Okay, so it is a powerful tool. It's possible to build, let's say, very advanced search portals based on SharePoint search. And I have read also about some Microsoft use cases where one of their customers supported over 100 brand websites using SharePoint Enterprise Search. The idea was simple. They had a bunch of small brands bought from different companies. And these brands had all their promotion sites, simple websites with not much logic or code behind them. But the problem was all these websites used practically some different solution behind the curtains. So some things were just a simple PHP scripts. Some sites were sitting just on some open source CMS, and technology-wise, it was pretty hard to get these brand sites under the same roof. So they used Enterprise Search to index these sites and to bring search features to all sites. So if your customer is searching from one brand site something, and this something has matches in some other website, then they can also provide results that may take customer to other brand sites they had. Okay, but now we have a cloud era. Our databases behind our web solutions are actually grown bigger than it was, let's say, in the end of 90s, and as we all know, then we can make search from SQL Server, by example, but it's not a long-term solution, because the more load we put to SQL Server, the more resources it consumes. If we suddenly need SQL Server cluster, it comes with a high price tag again, and suddenly we were in a situation where we need a search because we are able to gather a lot of data. Just wonder mobile applications, some popular ones, and those existing search technologies actually don't help us out. because Bing expects that we make all data public. It's out of question, probably. Enterprise search by SharePoint, it means that we have to deploy practically a whole SharePoint farm. We have to buy servers, we have to buy Windows licenses, SQL licenses, SharePoint Enterprise licenses, meaning that if we have, let's say, a startup that is in the early stages but making a quick growth, using SharePoint search would be out of question due to expenses. So, and then Microsoft decided to have a search solution that fits these modern scenarios. So it's not. It is still powerful. We have practically free hands to decide how our search looks like, how it works. We can configure it, but at the same time, it doesn't come with such a huge price tag. So, well, Azure Search is actually pretty well scalable. If you read documentation, then you will find out that up to 2.4 terabytes of data is supported without any involvement by Microsoft. If you reach this point, then you are not in a situation where you busted the service, but you have to make a call to Azure technical guys, so they enable you these higher limits. Search can be used by ready-made APIs. .NET and .NET Core both have libraries. If you happen to be on a platform that is not supported, then of course you can use REST endpoints and work directly against these. When I first created this presentation, then there was no library for .NET Core. So I built my own simple client library using REST API. Those who need to use REST API on some other platform, it's not actually anything complex to do. Practically, you are doing JSON format requests to a search service. You get JSON format responses back. So there is no tricky details involved. Also, you can use a search service from different types of applications. It doesn't matter if it is a web application or it is a mobile application or some desktop application. So these REST endpoints are available as long as a machine has an internet connection. And it's also easy to get started with a search service. There are multiple packages available or priced higher. So per one Azure subscription, you can create one free search account. It is, of course, it is limited in many ways, but not by base functionalities. So yes, with a free tier, you don't have so huge indexes available. You cannot put so much load as with paid packages, but it's still excellent starting point if you start building a search solution. Now, what happens behind the scenes? Actually, Azure Search is not something brand new. It is living actually on Elasticsearch. Are you familiar with Elasticsearch? How many of you? Okay. So, and Elasticsearch is built on top of Lucene document database. It's actually a pretty good decision to go with Elastic. Those who know Elasticsearch, who have hosted it, managed it, know that Elasticsearch is pretty powerful thing, but also kind of demanding, especially on the planning side, on implementation details, how you are building search on it. So Azure Search is living on Elasticsearch, but it is not Elasticsearch on a cloud. So there is a Azure Search interface between us and Elastic. And this interface is defining what and how we can do. So yeah, we can use, by example, Elasticsearch queries, but we don't have such a control over Elastic like we have with a self-hosted version of it. So we are still using Azure Search service, as a black box with a very well-defined interface. So now a few words about planning and building of search. Well, I can, like always, I can talk based by my own good or sad experiences, how things go, and what are the lessons. So there are two types of data you can put to search index. Some data is for searching, and there can be also additional data that is not intended for search, but it is needed to display search results. So it means that on a technology side, that if we don't have this supportive data to display the results, we have only part of data. It means that when we get the results back from Azure Search, then for every data item, we have to make request to some data store to get this missing data. So yeah, on one hand, we practically duplicate some data to search index, but on the other hand, we take again some load off from SQL database we have. Now, a very important thing is to understand what data should be in indexes. So sometimes people think that, okay, let's take data that is necessary for sure, but just in case, let's have some more data. Perhaps it is needed. My suggestion is don't take things that are perhaps needed. You can later always have these perhaps needed things if customer asks, but keep search indexes actually as small as possible. If you have to support multilingual data, it's pretty popular nowadays that sites besides local language also support English, by example, to get also some foreign crowd to user base. These scenarios on Azure Search are actually very well supported. With every field in index, we can bind analyzer. Analyzer is a piece of code that is able to analyze the content of field, separate words, understand how to do, let's say, stemming or lemmatization, and they are based on always on some language. Of course, it's there is also a standard analyzer that is used by default, but you can always go and let's say have for one field Spanish analyzer, to another field, you may have, let's say, German analyzer and so on. These analyzers come with two sets. One set is the set of analyzers provided by the Lucene document database, and the other bunch is by Microsoft. If you are considering performance, then Microsoft analyzers are slower. They put more load on the search service, but they are more advanced because instead of stemming, by example, they are using lemmatization. They can create search data that has a higher quality. So this is something to consider. If you don't plan to build big search indexes, then the difference between Lucene and Microsoft analyzers is not very remarkable. These differences come out probably if you have a big index that is under heavy use. Now, based on my own experiences, you may probably have sometimes customers who have the kind of mentality that if you order something, then let's take the full bang for a buck if possible. And these customers often say that, okay, we want to search by everything. For me, it makes red light blink and bells ringing, because search by everything doesn't have any meaning. If you are not able to explain to customer that we don't need all data available in search, then you can use a simple trick I'm sometimes doing. It's not very polite trick, but it works effectively. I think you all are able to write some HTML code. Okay, so make two HTML files. Example of search results. One HTML file. Let it be like real one. It looks like search results should look. Take it with copy and paste and add there some additional data from classified tables, by example. So, and then let customer compare these two things. On one screenshot, they see search data like it should be, and on the other screenshot, they will see what it means if everything is indexed, everything is in a search in a search index, and what users will see when they look from such a mess. It usually makes customers slowly driving away from this search by everything topic. And of course, don't make the bad mistake by duplicating the whole SQL database to search indexes. There is no point to do it. Search is a service for human beings, and and you don't want to confuse people, because now if you have too much unneeded data in a search index, then pretty soon you have new kind of trouble. How to get rid of this data in a search results? So keep indexes minimal and make sure they are there to serve searches with quality results. Okay, now, yeah.
So does Azure Search does security trimming? Security trimming, which means, yeah.
You mean security trimming like SharePoint is able to do?
Yeah.
No, Azure Search is not doing it. Security trimming like SharePoint is doing, because there is no such let's say, a user context automatically behind the data. Yeah. So, but still, it's possible. It's possible to implement something similar. But yeah, you have to then work out the solution how to do it exactly. Okay. Now, before getting to bits and bytes, my experiences on how these search indexes will be built, or how they are built. There is one little drawback with an Azure portal. When we create index, then we have to make a bunch of decisions that we cannot change after clicking save. So it means that if, for example, if we want to change some field type, we cannot do it easily. We have to recreate the whole index. As I understand, it all comes down to implementation details of Elasticsearch and or let's say hosting details. I understand that Microsoft is not very happy if indexes are changed frequently, because it puts the additional load to Elasticsearch and so on. But when you start building search indexes for new application, then probably you want to make changes. So every meeting with customer may introduce a bunch of new changes to a search index. So it means that after a meeting, you probably explode the index and create it again. I'm sure that after third time of creating index again, using Azure portal, you already feel like, why I'm doing it again manually. So write some simple scripts for indexes. You can do it, by example, using PowerShell, or if you have a program like a Postman to make HTTP requests, you can just have these JSON format request files, and if you need to change index, then you just modify your JSON file, save it, commit your file to source code repository, of course, and you can then create those indexes again very fast. And now if you're coming from application that already exists, so probably you have there some SQL server-based search solution anyway. Even if it's new application, what I'm doing, I define search interface and add at least 2 implementations. The main one that will be used in live is Azure Search. But if I have to do something with Azure Search indexes, suppose I have to explode index, recreate it again, fill it with data again. I don't want the site to not return search results. So I can easily switch from one search client based on Azure Search to a SQL one. Of course, SQL one must be written carefully. It will not be so good and powerful as Azure Search one, of course, but it still works. People can still find what they are looking for. And when I'm done with recreating indexes and filling these with the data, then I can switch back to Azure Search. Again, using ASP.NET Core or .NET Core, it's pretty easy to implement this kind of thing. And of course, if you want to be very sure that your search is functioning, you can also create a kind of fallback search. If search from Azure Search fails for some reason, or it doesn't give back any results, then you make this lightweight search to a SQL Server, by example. In this case, you don't have to change anything in application if you need to recreate indexes on Azure Search. So, but once you get the indices in place there, you don't change these indexes often anymore. But in the beginning of project, exploding index, recreating it again, is something that happens daily, not once, but probably multiple times. So, okay, but let's get to search features now. One popular thing is faceted navigation. Those of you who have worked with SharePoint Search probably know what it is. It is about these nice blocks we are seeing at websites. I have one a pretty topical website here, and here this alcohol volume slider is practically now one of these facets we can use. So with these kind of facets, we can coordinate search besides regular filters. We can add filters, but we can also define these facets and let user set some additional conditions to search results based on these facets. So if I'm changing here the slider, then after a moment we get back a little bit different results from here. So, oh, what happened now? Yeah. So something went down, as I see. Okay, but we got back a little bit different, a little bit stronger results. Okay. In a search, let me take here a search index. So we have a products index. Here we can see a fields definition. So, and here we can see that we have some fields that are facetable. So, for example, in current case, we can also probably, if we need, we can define same kind of slider for price, by example. So, now suggestions. If we have a need for, let's say, a fast search, we don't want to make so-called full-blown search to a search index. We want fast forward one. By example, user is typing something to text box. We want to just give user some suggestions. Okay, what you probably may want to search. So just advising user. Then we can use suggestions. Every field in the search index may have exactly one suggestion, and this is how it works. Okay, I take some bits and bytes from here. And I have here one example how these suggestions came back to us. Okay, so let us see. Okay, we got back something else than null reference exception. So, okay, so I got back some suggestions for a term beer, and now what happened? It was a special request to Azure Search, telling that okay, I don't want to get back all these fields that are given me back otherwise, description fields and so on. I just need something to provide user. So if suppose if I have a autocomplete box in a site, user starts typing search term, then I can give suggestions. So there is currently kind of similar thing coming to Azure Search that is called autocomplete. As far as I understood, then these suggestions will provide actually the results that take user somewhere. If selected, autocomplete will be something that is more guiding or advising and trying to provide these other search options. Okay, now let's take one a little bit more complex topic, tag boosting. Here in my sample, I defined some tags. I have defined tags, and now suppose that you are a customer of this nice store. So now knowing by ordering history some of your preferences, I can find out by example that you happen to like dark beers with high alcohol content. Okay, I will not tell it to your employer. Okay, but I have this information, and now my question in a light of search is, okay, can I do something with this information to help you if you are searching something? So, of course, it's possible to make some analysis and add new search filters, but I actually want to do it a little bit different way. I don't want to involve myself to search results, meaning that if I set filters to search, then these filters are considered when data is searched from index. I don't want to involve myself there. What I want to do is I want to just pull up these results that are probably most interesting for you. So, but I don't want to end up with results that are just where all other results that you probably are interested in are just removed. So because okay, I know you are preferring dark strong beers, but what if you are looking for let's say, what beer is popular here in Netherlands? Lentebock, by example. Yeah, besides Amsterdam, actually also Eindhoven metal meeting is very educating event to visit. Now, suppose you are looking for a lentapok, and now I force these dark strong pairs as a filter. Probably you get no single lentapok back. So now this is how we can now use a tag boosting. But tag boosting is part of something we call scoring profiles. Scoring profiles is actually a mechanism that helps us to correlate the scoring of search results. Every search result we get back from service has a score. The score usually shows us how good match this result is for our search. But the default scoring is often something that is not enough for us. And then we can use scoring profiles to fix the default scoring. So there are different scoring types available, up to, by example, a distance. So you can push up those results that by distance are more close to user than others that perhaps otherwise get better scores. So, and it's also possible to use function aggregation and other advanced ways to get better scores. So, but per one search request, you can specify only one scoring profile. So you cannot do things like taking multiple profiles and hoping that now they are correlating scores. There is no point to do it. One profile is enough. Okay, I will show you now how this thing works. Okay, here I have a simple class that is making a search request. So this class is actually working directly against REST API. I don't add any filters, but I don't do any other modifications either. And now I run the same code again. Okay, let's see what we got back. So we have here some bears, Mufflonator, pretty strong. Rodenbach Grand Crow is around 5 or 6, if I'm correct. I have to go back to Eindhoven. Echt Riekenbeer is around 5, and so on. Okay. Now, these results here, in a means of alcohol content, they are pretty jumpy. So now if I force it to use now this tag boosting profile, and where the hell it went? So I now force it to use a profile that is forcing my favorite ones up to top. So I'm specifying here that I want to use this scoring profile, and with a tag boosting profiles, we always have to specify the parameter. We want the items to match to get better scores. So I will run now the same code again, and now let's see what we will get back from search index. Okay, so now we have a little different situation. So QA to Chateau is around 11. By alcohol content, Mufflonator was anyway strong, around 9 something. Castile Triple is around 10 or 11. And then come those softer ones again. But as you saw, the direction or the order of results was now different. So same way you can use these scoring profiles to match user preferences also in other contexts. So if you know that some of your users happens to like green jeans, by example, when for some reason he needs a lot of green jeans per month. So you can same way create scoring profiles and then match these profiles with your users' experiences. It is if your search index is not very small, then perhaps scoring profiles doesn't give such a huge effect. But suppose you have many products, you have thousands of products, then probably these scoring profiles will make life of your users way easier. Okay, now a few words about automation and monitoring. There are things called indexers. So we can in our code we can always write some intelligent search service and use this service to, for example, to also update search indexes in real time. So if somebody added something new to a product database, then we automatically add the same product also to Azure Search index. Okay. Also, if we don't have some very huge database, we can write some method to our search service that goes through all products in our product database and adds or updates the product data in Azure Search index. This way, updating indexes is actually something I like because the objects in our domain model have usually different structure than what we have in the search indexes. So, but what happens if we cannot use such a real-time index updating? There can be a lot of reasons. Now we can use indexers. It means that the data is automatically read from some source and then added or updated to a search index. So we don't have to write any code for data updates in our application. if we take data from, for example, from a SQL database or document DB or table storage, then we can add indexers that do it automatically. We can also schedule how these indexers actually work, and then everything starts suddenly happening automatically. So these indexers are run by a schedule. Data is dragged from, let's say, SQL database. It is added to index, or deletes are made, and our application is practically free from this kind of logics. So it's also possible. Pretty fancy indexer I found is indexer that is going to indexes kind of like a static pages from a website. So practically what we can do. Have you heard about Azure Static Websites service? Raise your hand, how many? Few of you. Okay. It's practically blob storage that can be used to host static website. So it's a perfect match if you need some promotional website that doesn't have any logic behind it, or at least if you have some logic, you can implement it in JavaScript, by example. Now, if you want to bring search to this static site, you can use Azure Search with static website indexing. So it is going to index automatically what you have in a static site, and you can also use JavaScript to communicate with Azure Search. So suddenly this otherwise static site is fully searchable. So there are limitations, of course. You can do only indexing, only search requests to Azure Search from JavaScript. You cannot do any other requests that modify index somehow. So, but for a static site, I think it's more than enough. So, and it's possible to use application insights together with Azure Search to monitor what are your users actually searching from a website and what results they get, and additionally how your search is actually performing. It actually, if you want to get kind of a good results, then you have to make some coding work. So using application insights APIs, you have to add analytic events when, for example, when a user clicked on some search result. So in this case, the data about the fact that user found something useful from a search results is saved to application insights, and it will be visible for you. So these reports can be also visualized using Power BI. Power BI should be familiar for most of you, I think. Yeah, it's not such a new service anymore. Okay, Power BI has a spatial visualization available. So if you have a search monitoring activated, then it's pretty easy to get it all to Power BI. It's practically preset for you already if you create this visualization stuff. And here you can see a pretty good overview of how a search is functioning. Also, perhaps one interesting thing is zero result search queries. If you have search, then this is actually the piece of information you have all the time keep your eye on. Because often users may use a different language. If you sell something, probably you are using official language. You don't use street slang. Now comes, let's say, some young guy to your site, and what he is typing to search field is a regular youngster's slang. And your search gives back 0 results. So actually, you can use synonyms on Azure Search for these scenarios. So, but of course, you don't get this list to 0 this way or other, because sometimes people just search for things you don't have. So, and these searches will always end up here. But still, this block will give you very good idea if and how you can improve search of your site. Okay. Okay. As I see, then we are getting to end of the presentation. I will answer questions after closing here. Anyway, those of you who consider using Azure Search in some real projects, there's no reason to hold yourself back. Go do it. It can be first a little bit complex, or it may seem like something big, but actually, when you make a start, you start going, then actually you find out more and more that this is a service you need. Also, they have very good documentation available in web, and as you saw, then you can keep your eye on what's going on using Power BI. Okay, thanks by me, and those who want to ask questions, come and ask. Thanks.